Astronomers have taken what might be the first ever picture of a baby planet being formed. It looks like a beautiful tornado-shaped spiral of light, and you can see a tiny twist inside one of the arms of the spiral. Why is this an achievement? And how can you actually tell whether there's a planet inside that tiny point of light? I asked Anthony Boccoletti, who led the team from the European Southern Observatory, in taking this picture.
It looks like what we call a spiral arm, but this spiral arm has a special twist which we could expect to be the presence of a planet.
The reason for Anthony's hesitance is that this isn't a picture of a baby planet. It's a picture of what could be the effects of a baby planet being born. If you look at it, what you're seeing is a spiral of gas and dust orbiting a star called AB Aurigae, which is in a constellation called the Charioteer. The star is about 500 light years away from us.
The system is very young, so the star is a few million years old. And at this age, we still have a lot of gas and dust around the star, forming a disk. And in this disk, we have structures, in particular spirals. And when we see spirals, we have a hint that there are some other bodies creating this kind of perturbation.
By perturbation, that sounds like something just disrupting things. How do you know that's a planet?
It's difficult to connect exactly the perturbation to the planet. We think it could be a planet, but it could be also an object which is more massive than a planet, depending in fact on which model you consider.
Here's how they got to this point. They used a telescope out in the Atacama Desert in Chile, the wonderfully named Very Large Telescope, to take pictures using light that's near the infrared part of the spectrum. They were following a tip-off from a different telescope that this star had some potential protoplanetary stuff going on. But the difficulty is to get a good picture of something that's so close to its star. That's like looking up at the sky and trying to spot an airplane as it flies over the sun. So the team's solution was to use a powerful planet-finding instrument called SPHERE, attached to the Very Large Telescope, that can take pictures at extremely high contrast. University of Cambridge astronomer Carolyn Crawford wasn't involved, but was enthusiastic.
I think it's fantastic because you're beginning to tie together what we learned from simulations, how these planets form the disk, with actual observations. AB Aurigae, this system they've imaged in such detail, is comparatively new. In terms of it's a young star, it's comparatively nearby, but it shows these structures in so much more detail than we've got with previous protoplanetary disks.
What are the chances that that's how we formed? That's how Earth formed?
It's getting this observation. We're a long way from determining how exactly an Earth-like planet formed.
This baby planet, if indeed it is a baby planet, is also more like Neptune than Earth in how far away it is from its sun. But Anthony Boccoletti and his team can still theorize about the general principles that this might imply.
So yes, it's difficult to capture exactly the moment when the planet forms. So it's really information about what we call the initial condition of the formation. For example, the presence of the gas, how much gas, the presence of the dust, and especially the structures.
It's sort of a recipe that could be for how a planet forms.
Yeah, it's really the very beginning, probably because we don't see the planet yet. If it is a planet, it's still buried in the gas and the dust.
If it is a planet, how long before this baby planet sort of gets born, becomes a real thing?
Probably a few million years.
Oh no! I was hoping you could look again in a couple of years, maybe see it.
We will have to wait a bit longer.
Anthony Boccoletti from the European Southern Observatory, whose paper is out in the journal Astronomy and Astrophysics. And you also heard from University of Cambridge astronomer Carolyn Crawford, an independent commentator.